Good morning and good afternoon and even good evening, everybody. Welcome back and welcome to our new members as well. This is the last day of the training sessions at Security Summit, but there is going to be actual summit next week. So don't forget to register for those sessions as well. So a warm welcome. I hope you have been enjoying the sessions, and I know I have been, and I've learned a lot in these 2 weeks. But for anyone who's new or who's just catching up on YouTube and have never heard about us before, Open Security Summit is it's a non-profit community where people from all different walks of life come together and discuss things about security and how to make better security for the companies and for the general public as well. So in these sessions, we do expect and encourage your participation, because we all get more when we can discuss things further. And sometimes one person's question takes us to the next level. So don't be shy. You can unmute yourself and ask the questions. Or if you don't want to interrupt, but he wants to be interrupted. He likes to be interrupted. So if you can, unmute and ask. If you can't, you can use the chat window in Zoom, and I will be monitoring that. Summit. So it's in the name, Open Security Summit. We do record everything, and we share it on social media and on our site, so that other people can build up on the knowledge we are creating here, and people can go back and refresh their memories if they need to as well. So no secrets here, but there will be some secrets in the lab, I guess. And respect. This community is very diverse. We wouldn't survive without diversity, because we all need each other. So we expect everyone to respect each other, and we know they do. So it's a bit, it's there. Anyway, that is me. So this year's hashtag is OSS 2020. Please share it generously, and some of you have come here today because of this hashtag. So the more you share, the more people we will reach, and the more people will get benefit from the summit. And we do have a Slack community, so even when the summit ends, the conversation goes on in Slack. So please do join. I will be sharing the invite link in the chat in a minute. Over to you, Imran. Imran is going to run us through the theory and the lab. And yeah, don't be shy. Yeah.
Thank you, Dida, for the introduction. Happy to be here once again, and looking forward to more interactions and discussions, just like we did yesterday. It was fun, really fun. Okay, let me share my screen. Hold on. Just to give me a minute.
No problem.
I had to reinstall Zoom because it was not picking up microphone. So let me give me a minute. Just re-enabling.
Anytime, if anybody wants to introduce themselves or what they expect or anything, you can jump in.
Okay, looks like I have to join in again. Just give me a minute.
Fine.
Hello, everyone. Welcome back. I guess I am back. Thanks a lot for the patience. So we had a little bit of technical difficulty in there. Once again, we are the training sponsor for this year for Open Security Summit. But we are also pretty much involved in the community, which I will share in a bit of time. So we are the premier DevSecOps platform. We are one of the well-known DevSecOps certification providers in the world. And all our trainings are pretty interactive and also pretty role-based. So if you are a manager, we have a training for you. If you are a technical person, we have a training for you. And then the reason why we started this is to promote DevSecOps education, and Open Security Summits is a very good opportunity for us to contribute back to the community. And this is one form of our contribution to the society and to the broader OWASP community, from which we have learned a lot. So once again, thank you, Didar and Open Security Summit, Dinesh, for the opportunity. Really,
And
really
I did
appreciate that.
forget to say, you guys are our training sponsors this year. Practical
Yeah.
DevSecOps. So thank you again.
Yeah, thank you. And then, as Dida mentioned, right, we provide certifications. We have a bunch of certifications here, as you can see: DevSecOps Professional Expert, Architect, and Leader. And we are not your typical certification body, because our exams are not multiple choice questions, but rather challenge based. So you have to finish 5 challenges wherein you will implement DevSecOps pipeline within 12 hours. So our exams are 12 hours of duration. So it's not like everyone can gain that by sitting a 1-hour exam or so. Okay, so as part of the community efforts, we organize different meetups and workshops on a regular basis. So our next would be from Vandana. She's also from OWASP. She's a board member now. So she will be speaking again about DevSecOps. So please feel free to join that. We also run a free newsletter as well for the community, and we do a bunch of open source projects as well, contribute back to the OWASP project as well. So that's why we are also here. And as we discussed before, I ran the DevSecOps track of Open Security Summit in 2018 and contributed a bit to 2019 as well.
Wandan is also having a session today on OWASP Web
Yeah.
Security Testing Guide.
Mm-hmm. Yeah, I'm looking forward to that. So as I mentioned, we do these trainings across the world in conferences like Black Hat USA, EU, Black Hat EU, DevSecOn, BruCon, bunch of other places across the world. If you need to catch up with me after the talk, please feel free to reach out to me at SecVigo, and we can definitely chat about DevSecOps, application security, and whatnot. So a quick poll before we get started into this one, because I've already covered this in the past 3 sessions. We did cover this in static analysis, dynamic analysis, dependency scanning in the previous 3 2-hour videos. If you haven't, you can definitely go check that out. But just quick survey here. How many of you know what is DevSecOps? Please do say yes or no, so I can have some idea on how much.
Use the yes no buttons in the participants window, if that's easier. Thanks.
Okay. Fair enough. So I think I'll spend 10 minutes to cover this quickly. Otherwise, we spend half an hour or so here. I'll skip this because all of you know about that. Okay. So basically what I'm trying to say here is that there were problems in how you do software development with the help of waterfall models, right? So that problem I call wall of certainty. It's a made-up term by me, so you will not find it online. So there was a disconnect between what business wanted versus what development team wanted, right? What they delivered to the end user. And in order to solve this disconnect between business and software development, they came and then thought about different methodologies. And one such methodology is Agile, and how we can, instead of fixing requirements once in 6 months, let's iterate through it on a regular basis, on a regular cadence, maybe once in a month, once in a week, or whatnot. Right? And they were able to solve that disconnect because you're now getting constant feedback. Again, the keyword here is feedback from the stakeholders, which could be your customers or external customers or internal customers. And then based on their feedback, we will correct our course. Are we on the correct path? If you're not, okay, then we'll correct our course and then move to the right path. Right? So that's the problem Agile solves. Now, because a good side effect of Agile is that you will be using techniques like Scrum, Kanban, and then you will be trying to push code to production every few days. Right? Some organizations, they do once a month, some do once a week, some even do every 9 seconds. Right? Every 9 seconds, someone is pushing code to production. I know companies like Etsy, they push to production every 45 times a day. Some organizations do even more than that. Some organizations do less than that. right? Whatever your cadence is, now you have a huge problem which operations teams had to face, which is kind of now developers are trying to go to production on a very rapid pace, but operations couldn't keep up. Now security is also in a similar boat right now. So we can learn a lot on how they operations solved this problem, right? And that solution to that problem is DevOps, right? Now, there is no well-known or accepted answer to what is DevOps, just like Agile, right? Agile means different things to different people. Same is the case with DevOps. DevOps means something for someone and something for someone else. For example, I asked a dude, okay, what is Agile for you? He said, okay, we do daily stand-up. My manager used to take our kind of feedback once a week. Now he takes on a daily basis, right? That was his definition of Agile. And then when I do ask what is DevOps, some people do say, oh, the operations team, they just renamed or rebranded themselves as DevOps. So there's a lot of funny answers, and then there are serious answers where they say we are going through this digital transformation where we want to add value to our customer on a very regular cadence or on a regular frequencies. Instead of deploying or providing value to our customer once a week, we are going to deploy once a day or once a week. So in my 10 years of career, or decade of a career, I have seen companies who deploy to production once a year. I have seen people doing deployments like once a month, and I've also seen people do deployments every few seconds in an organization. So no matter where you stand, are you a traditional conservative company or pretty startup-y unicorny, then definitely you can make use of DevOps concepts. Now you see, now there was a disconnect between development teams, software engineering, and quality assurance, so to say, operations teams. Then they solved it with the help of DevOps, right? And because of that, they were able to iterate it in a very faster phase. And as you can see, there is no beginning and end here. It's a continuously iterated process. Now, because of this, they became a team. DevOps now became a team, right? Now, the next person or entity or a team, which is a bottleneck in this whole flow of SDLCs, secure software development, is your security. And typically, most organizations have love and hate relationship with security, because some people don't like to work with security because they are slow, they are scared about them getting hacked, because we are now pushing code to production every 9 seconds. They are not able to keep up with it, in the sense we cannot do pen test every 9 seconds, or we cannot do compliance every 9 seconds, or what you have, right? Like pen testing, source code review, threat modeling, you cannot do it every 9 seconds, right? Now, and unfortunately, our toolings, at least what I've seen in the market these days, is 60 to 70% of the tooling which is available for security in DevOps world, which fits into DevOps, is 60 to 70% of them don't fit, basically. And the rest, you have like a 30 to 40% of them, they do support DevSecOps practices, but some of them support probably like 60 to 50% of it. But there are only a handful of companies which supports the entire process of taking you through a DevSecOps pipeline. And many people are trying to do this at the moment, but it's still not a mature industry as such, like a product security or application security as such. So we are still seeing more and more companies in the industry, and they're trying to innovate. And I'm really, really excited for a couple of companies. Let's see how that goes. Right? And then if we do follow DevSecOps practices, then we will be able to achieve massive gains in terms of how we achieve product security, information security, network security, whatever you call, in a very systematic way. And this is what we call DevSecOps. Now, another problem which DevSecOps solves is that no matter which organization you work for, even for Google, they have like hundreds of engineers, but compared to their developers, right, they are tiny. What do I mean by that? So, for example, a typical ratio we see in the organizations is for every 100 developers, we have 1 security engineer. And I'm just being here very conservative, but some organizations which I have seen, they have for every 500 developers, you have 1 security engineer. So obviously we cannot compete our scan the code or do pen test on every application which development team is creating. And when I say security, I'm using it in a very broad manner. For example, I'm definitely talking about both, audit compliance teams, red team, blue team, purple team, if you have all of them together combined. And this could be worse for some organization. It could also be less for some organization, but it typically falls around that. Like, I have seen some organizations where they have like for every 2,000 employees, they have one developers, they have one security engineer. So it's going to be really, really tough, at least in the DevOps world, to not automate or not to build that culture of measuring, and then sharing your workload across the organization, right? We always say security is everyone's responsibility, but then we have to bring in that culture of, yes, this is my responsibility, and bring in that definite change that everyone not only thinks that it's part of their job, but it's a responsibility of theirs to make sure the customer data is safe, secure, and then they are providing value to their customer, right? So this is one of the problems which DevSecOps solves for us. Okay, and personally, I believe there is no such thing called DevSecOps, because when people were talking about DevOps, inherently the security was part of it, at least as part of operations teams, right? But just like everything else, we are at the end, right, of software as DLC. We came in late. So DevSecOps is the movement now to solve that, right? Now, you might even call this Sec DevOps or DevOps Sec or whatever you have, but I can give you a very strong arguments in every use case, right? If you say the security has to come first, I have to completely disagree with you, because if there is no business, there is no need for security, right? You have nothing to secure, so what are you going to do with security? So the Sec DevOps doesn't fit there. You say, okay, if you say DevSecOps, oh, probably then we are saying now you should do development first, then security, and finally operations. Again, that doesn't hold true as well, because remember, we have to do security and shift left security, do security from day one, not day 2 here, something like that. Or if you say DevOps Sec, then are you saying we should just follow a typical methodology wherein you're doing pen testing at the end, right? So no matter what terminology you push for, you give me, I can give you very good arguments like, oh, that's not going to happen, right? So again, so we are using that term as a way to communicate the idea that we have to think about security as part of DevOps. Now, where it depends on the context, right? If you are a waterfall, if your organization is using waterfall model, probably you don't have any choice, and then just still continue the traditional methodologies. But if you are using DevOps, cloud native, Kubernetes, Docker kind of technologies, then you do have the culture needed or technology needed to implement DevSecOps, right? And I'm not here to debate on what is right or wrong. This could be, and these discussions turn out to be pretty rough sometimes, because this is like a similar debate about Windows versus Linux, Vim versus Emacs, and whatnot, secure red teaming, purple teaming, or pen testing and whatnot. So I'm not here to debate, but whatever your definition is, I think we all have to agree that we have to do security as part of DevOps, right? That's what we are talking about here.
But we haven't received the question specifically about that. Like, do you think red, blue, and purple teaming will fuse together?
They have to in some way. I know, like organizations like Lyft, they are like Uber's competitor in USA. They don't have these functions, like they don't have operations, security operations, application security team, compliance team. Everyone is part of DevOps teams, and everyone shares some or the other workload. And there's definitely a need for specialization. Let's say, for example, you are from a compliance background. You cannot help organization if they don't know in and out. But then even them, they automate compliance with compliance as code. So they are hands-on as well. And I know organizations like Netflix, what they do is they even expect their director level employees to be hands-on and contribute code to the production. That's how hands-on they are. So, and eventually, this is my personal opinion, don't quote me on it. eventually we will not have these segregations as well, right? Like red teaming, blue teaming, and purple teaming eventually down the line, probably 5 to 10 years, probably realistically 10 years down the line. Because if you see here now, software is eating the world. Now, you guys might be using Amazon, right? How many of you really know what's going on a network level? They're using software-defined network, but all you have to know is, okay, this is how you set up a VPC and you're done. You don't need a dedicated network engineer how you used to when you were running dedicated data centers, your own on-prem data centers. Now we don't need it. So there's a huge shift in the organization where we are moving away from center of excellence kind of setup to more everyone shares responsibility, and then we hire for specialization, right? So we want more generalist than what do you say, experts. Okay, so this is where we are moving. So eventually, yes, we will see that blue, red, and purple teaming will fuse together, but there's definitely a need for specialization at one aspect of it, but not many would be doing, probably a couple of them, and everyone would be generalist, right? So, and we are already seeing this. And that's another reason why I ask people to, security people especially, if you don't know what is DevOps, learn the basics of DevOps. Now is the right time to do it, because that would make you employable, more so in this situation, and also will give you a necessary knowledge or necessary things to talk about with your DevOps team. Unless we know what they are into, they will not be able to understand it, right? So we would have things to talk about and share their pain. And unless, just like how we do in pen testing, right? If you want to attack, I come from a pen testing background before I jumped on the DevSecOps bandwagon. So if I have to attack application, I have to first know what it is doing, why is it doing, and how is it doing, right? And then you will be able to attack it. But if you constantly try to just put tools on it, then probably you will not find a lot of vulnerabilities, especially in the new modern secure by default frameworks. You definitely will not find anything unless you think logically how this app is working, how everything is working together. So right, just like that, we have to think holistically as well. So another question I have is, so would it make sense to focus on getting few experts and the rest are more dev-oriented? I wouldn't say dev-oriented, but more generalist in the sense from a security perspective as well. So for example, what Amazon does is they have this concept called two-pizza team, wherein your team should not be more than, for lack of a better number, I'm just saying like a 10 people, which can feed, you can feed your entire team in 2 pizzas. So whatever that could be, if you have a good people, then probably 6-7 people would be max in a team. But some of them will, most of them will do everything, but some of them specialize in operations. But then everyone is responsible for operations. So you create it, you maintain it. That's the concept. Similarly,
More
we can
people use the tribes, right? So everyone has the same mandate, but according to their skill sets and interests, they form the tribes.
Yeah. So that's also something you can. And again, there is no such thing called, answer or correct answer. It depends on your context, your organization culture, how mature your management is in terms of understanding the DevSecOps transformation and what. It depends on a lot of things. So I'm generalizing few things, but this is just to make you understand stuff, nothing else, right? There's no right and wrong answer in implementing these things, right? So now, in order to do DevSecOps, you have to do these 4 things. And if you don't do even one of them, then rest of the other aspects of DevSecOps will suffer. What do I mean by that? Let's say you spend $2 million on buying fancy automation tools, expensive tools, state-of-the-art technology, and you don't have culture, then you would waste all of that to $2 million. And I've seen this happening. Right? It's not like a one-off. Oh, I don't have to work on. I only have to work on automation because that's the fanciest, nicest aspect of DevSecOps. But you also have to continuously give feedback. Remember, there was a feedback loop between the business and the development, and then development and operations. Now we have to learn the concepts which operations have already learned, which is share your responsibilities with the development team, share your best practices with development team, share your analytics, metrics with the development team. So replace the operations aspect and replace that with security. So security has to share their automation with the development or DevOps team. They have to share their metrics with the DevOps team. They have to share their best practices with the DevSecOps team, right? So if we do that, we can build that culture of security is everyone's responsibility. We talk a lot in the industry that security is everyone's responsibility, but we all know how much is it, how much value or truth is to that, right? So think about for a second, like look at your organization. Now, everyone says that it's everyone's responsibility. How many of them really look into that, right? That's another thing. There is another interesting side effect of this as well. Okay, side effect of DevOps or DevSecOps. Again, it's not perfect, just like everything else in the world. It does have some of its problem. For example, now you are expecting a developer to also take care of operations, correct? Now with Agile, you are also expected to take care of testing. So you are asking a developer to take care of testing with Agile. Now you're asking him to take care of operations with the DevOps. Now with the DevSecOps, we are asking our security champions to take care of security. Now, should that guy be doing his job or help you, all of you, right? A very important question to think about. And he already is bombarded now. He has to learn now. He has to become full stack. He has to learn about front end, back end, bunch of other new technologies, queues, stacks, and whatnot. It's just crazy. So even asking someone to spend a lot of time on security becomes challenging if we don't have right set of culture in the organization. So it's very, very important we follow these 4 aspects of DevSecOps, right? And then just to iterate this point enough, if I haven't stressed it enough, if you don't have culture, everything else falls down, okay? Falls on knees, basically. So we have very interesting law called Conway's law, which says if your organization works as a hierarchical, then the software you create will also be hierarchical. So maybe let's say if you have to go to a conference, your boss needs like 10 approvers before he can send you. The software you create will also be like this. Oh, approve, 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 right? Whereas if you are using Agile or DevSecOps, these kind of SRE methodologies, then the software you create will also be like that, very frictionless, very smooth, user-centric, and users will love to use this. And typically you see these coming from unicorns like Uber, Netflix, Facebook, Google. All of these services are like that because the culture allows them to build such innovative functionalities or innovative features. So if you can create that, and Netflix is a very good example on how they managed to do this, right? So they were moving from kind of monolith kind of architecture to more microservices. It still took them 6 years to go from monolith to microservice, but they eventually did that. And then that's a typical kind of a favorite example everyone gives in DevOps or DevSecOps. So definitely look into it. From a implementation perspective, we have to shift security left, just like how operations are shifting left. We have to create self-service mechanisms, whatever that is for you, static analysis, dynamic analysis, and use everything as code because it helps you drive compliance efforts, auditing efforts, and also gives this feeling of that, okay, securities, automation, hardening scripts are here. Anyone can use this to automate their infrastructure. So you can just create that as a self-service model for everyone else. Or you create golden images and everyone use that. So again, the different models, ways of doing it is one such one. And use secure by default frameworks. So you try to make everything secure by default. For example, I've seen someone on Twitter complaining, oh, my CFO just clicked on a malicious link and he got hacked. Now, to be very honest, it's security's responsibility to ensure even if they click the malicious link, they should not have side effects because we cannot expect a CFO to know nitty-gritty details about how phishing works and all of that. And to be very honest, I have seen even security people getting pawned clicking on malicious links. So it's not, and if security people are themselves are not safe, then how can you expect someone like a CFO who doesn't probably have a lot of technology experience to not click that link? So it's our responsibility to create such automation, right? And then use security champions a lot so that you can encourage developers to pick up securities tasks, like help them find, fix issues early on in the pipeline. So I think this is what I believe what DevSecOps should be. And no matter which tool you're using, are you using a paid tool, or are you using a free tool, you can implement DevSecOps. You don't need to have a fancy tools to do that. Okay. So in short, what we can conclude from these things is that automate everything, whichever you can, make it self-service, and drive consistency through CI/CD and immutable infrastructure. Now, if you can't change infrastructure directly by logging into a system, then you can assure the integrity of the image. And if you want to deploy something new, they have to go through this whole process, CI/CD process, and then improve the workflow, improve the tracking. And when you improve the tracking, we have this famous saying, right? If you can't measure it, you can't improve it. Same goes here as well. So yeah, and then use the tools which developers and operations teams are using to do security job. What do I mean by that? Let's say your team is using Terraform or CloudFormation to spin up Amazon or cloud instances. Then you can use that information to harden those scripts automatically without any involvement from development team. Right? Obviously, there needs to be testing to ensure there's no side effects. But if you say, okay, if you have to go live, you have to use this Ansible script, Chef script, Puppet, Chef recipe, Puppet scripts and whatnot, then you don't have to get involved on a regular basis, right? So you can scale your efforts like that. So use the tools which developers are using. If you're using something like Jira, try to push your issues in Jira. Of course, that might have some compliance implications, audit implications. For example, we don't want everyone in the organization to look at that vulnerability. Right? Maybe you can pick up security champions to handle that kind of security. Different ways of doing it. There is no silver bullet here, but you can definitely add value here as well. Okay, so that's the introduction of DevSecOps. Now, do we have any questions before we move on? You can definitely disagree with me here. I don't mind. Any questions?
No questions as
Okay.
of now from my side.
Great. Thank you. Okay, let's get right into the lab setup. So this is a practical lab, right? So we are definitely going to set up the lab here, right now. Now the way we have set up this lab, it has the bare minimum DevOps, what do you say, critical tool chain, right? You definitely need a place to store the source code. So we have a Git server here. You need to run tests, which could be security or otherwise operations tests. So in order to run that, you need CI/CD server. So we have a CI/CD server here as well, and then you have a runner, also known as a way to delegate your task to some specific server. And then you also have a prod server here, right? So the DevSecOps training platform which we created, it has all of these components built into it. And you can replace these components. Let's say you are using GitHub rather than GitLab, or you're using Jenkins instead of GitLab, or using Jenkins slave machine, then you can use that as well. And if you're using Docker containers, again, you can replace that, whatever. So in our courses, you can pick up, okay, do you want to use GitHub as a SCM, or do you want to use Jenkins as CI/CD platform? But for today, we're going to stick to GitLab because it's very easy to use, and you can transfer this knowledge to other CI/CD systems or version control systems, right? So we have created this pipeline. Now, this machine, GitLab machine, has a version control system and CI/CD in it. There is another machine called runner machine where you will run the jobs, and then you also have a production machine where we will deploy the software before we do dynamic analysis scans, be it DAS scans, IST scans, let's say WAF configurations, or you can also do compliance as code, security as code, hardening, and a bunch of those things, like creating golden images. All of that can be done irrespective of the technology. So technology doesn't matter. That's what I'm trying to say. So if I have to put it in a pictorial form, this is how the lab environment looks like. And this is our basic lab. So what you're seeing at the currently, we have more advanced labs wherein you have more systems involved into it, more technologies involved into it. Like we might use something like some system like Docker registry or JFrog and whatnot, right? You can configure all of that, and we can do this entire thing in AWS, GCP, and Azure. Whatever your current stack is, we can definitely do that. So that's the lab. Now let me show you a demo of how that is done in our platform. So this is our DevSecOps training platform. This is one of its kind in the industry. And then as you can see, there's a bunch of tests, a bunch of exercises we have. Some take 10 minutes, some takes like half an hour or 1 hour to do. For example, if you have Ansible, automation, hardening, Docker security as part of CI/CD, then it takes a bit of time. But then these exercises, which we have provided for all of you, takes about 10 minutes, give and take, right? So let me show you what example. Not secret scanning, but let's do, let's say, yeah, let's do Bandit. So this is a platform. We start off with the introduction of what this task is about or what this technology is all about. So this is on how to run static analysis tool on a system. It could be a developer machine, it could be a security engineer's machine, or it could be operations machine, whatever that is. And then I'm going to click that start exercise button, and you will see that once you log in, you can read what this tool is all about, how that's working out, and whatnot. And then in order to do this exercise, you just have to click on the button where there's a red text. This text, if you click on this, it runs that command. You don't even have to type it because it's all there on the server. Right? Very easy to use. You can even do this on iPhone or iPad. You don't even have to have a system like this. You can just sit in your couch and just click on this buttons, right? So let's go into this one here, and then finally, what we're going to do here is we definitely explain you what we are doing there. Click on that, and then finally, eventually, we run the scan. Okay, whatever that is. So we found medium issue here. There is a high severity issue and whatnot. Okay, and this is a full-blown operating system. You can definitely look at, let's say, I want to look at the Bandit output we just saw. So you can just use that. Yeah, there you go. So this is a similar issue. Yeah, so this is a platform. Very easy to use. Just follow the instructions and you are done with it. Okay, so this is our lab setup. Hardly takes 5 minutes to anyone to set it up. Now, if, for example, you were not here with us yesterday, what you can do is click on this sign up and please fill up this form, okay? Don't use LinkedIn and Google. We have disabled it. And yeah, add information here, sign up. You should get an email from us saying, hey, can you please confirm your email? Once you confirm, you can come here, log in, and click on the courses. Right? This is the tab you have to click on. And once you do that, all you have to do, as I mentioned, just click on the start button, and that's it. You're done. Right? Start the exercise, and you are done. Okay, so this is a platform. Now we will spend 5 minutes to make sure everyone are able to access this. Again, as I mentioned, you can do it on an iPhone or iPad, even on Android phones. Please feel free to use that if you think there is no system available for you. Go ahead, 5 minutes. So let's move on. Can you? Okay. So next up is we have to now learn about static analysis. Right? Now you might be wondering, we are in a secret analysis lab and he's talking about SAS, right? Why is that? Because any form of scanning where the code is not running, right, is a form of static analysis test. So even secret scanning tests are part of your static analysis tests. So wherever you can use code, especially in the build stage or in the testing stage or in the coding stage, you can definitely embed secret scanning there as well. Now there are three different ways of running secret scanning. I'll talk briefly about that once we cover the static analysis. So what static analysis means? You are looking at the code and trying to see if there are any security issues in it. That's it. That's the whole definition of what is static analysis. And there's a lot of technical jargon in there, talking about program analysis, whole programming analysis, and whatnot. But for us, for our use case, we have to understand. You look at the code and try to um, reason about reason about vulnerabilities. Right? That's what we are doing. And since it's not being run, it's not called dynamic analysis, but rather static analysis. So that's what we're gonna look at it. Think it more like a glamorized grep, or even grep is your static analysis, right? Yeah. Now, when it comes to now each technology you use, right? You have to first understand the fundamentals. If you don't understand the fundamentals, then excuse me, these tools will scare you, right? And you also have to know what are its strengths, weaknesses, and where they are, where they shine, and where they lack in feature set, right? So strengths are that you can just start right away. You don't have to set up infrastructure. You don't have to do anything. You take the code, either it could be a zip file, git, git pull or whatever. You can just give that code to a tool and it will do your job. It's very simple to get started. But when it comes to problems, right, just like everything in life, nothing is perfect. So when it comes to weaknesses, it gives you lots and lots and lots of false positives. Okay. And even some people call it as false positive as a service technology. Right? It could be so bad. But I don't believe in that term, because if you can configure it properly, then it does provide lots of value. So there's definitely value for that. So we should be using it, right? So by its nature, as I mentioned, is prone to high levels of false positives. It's not because the technology itself is bad, but then in everything we make some decisions. Or let's say we say, okay, if I want speed, I can compromise on the quality, and if I want quality, then I should not be thinking about speed. So if you're worried about speed, then you should not be worried about quality, and vice versa. So there's a lot of parameters in there, and it also depends on how much computing power you have. For example, if you have a big source code, if you run on a supercomputer, it might finish within 5 minutes, but a mom and pop shop cannot afford a supercomputer. So then we make a meaningful decision in the sense, oh, I don't want super nice or super accurate information, but I want you to finish within 10 minutes. If I want super accurate information, it might take 10 years for you to get the results. So would you be interested in waiting 10 years to get a result? Probably not. And this is more, this is so much of truth is to this weakness, specifically in DevOps environment. And you should not run any tool which takes more than 10 minutes in a CI/CD pipeline. And if you do that, you will have a very, very bad time implementing security as part of DevOps. But again, I'm not saying that you should not run full-blown scans. What do I mean by that? You can run baseline scans as part of development pipelines, but you can run full-blown scans as part of QA or performance pipelines where they are running this tests. So you'll do static analysis, but probably incremental scans in the development pipeline, and full-blown control flow analysis, data flow analysis in the performance or QA tests or QA pipeline, right? Are we clear on this? Very important to understand, right? And definitely don't, for the love of God, don't fail the builds. Why? False positives, right? So imagine that someone, if a cop gives you a note saying that, okay, you violated this traffic at this point on so and so date. And if you look at the camera picture and then you realize, oh, this is not me at all. This is someone else's bike or someone else's car. But your IR was problematic. You couldn't do image processing properly, and you thought that's my car, but in fact it's someone else's car. My car is pink, but your car, the car which I see in picture is a blue car, so that can't be me, right? So you can see that like similar thing applies to static analysis as well. Okay, it gives a lot of false positives, and if you configure it properly, you can definitely add lots of value to your organization. So the keyword is configuring it. And let's say if a vendor comes to you and say, sir, we came up with this awesome static analysis technology, it has 0 false positives, right? Again, 0 false positives. If someone says that, then probably he's trying to sell you a snake oil, right? Theoretically, it's not possible for you to have 0 false positives when you're using static analysis. Why? Because you're making compromises here. Remember the quality, speed, memory, and CPU processing versus memory power. Yeah. So if you think you have unlimited resources, unlimited time, then yeah, there is no weakness at all in static analysis. It's amazing by its nature, right? And that holds true for all static analysis tests, be it the code analysis itself, be it configuration checks, be it secrets, what have you, right? And then many of them don't fit in CI/CD pipeline unless you configure it. So you have to definitely configure it. You have to write rule sets, tweak it according to your infrastructure, tweak it according to your custom built libraries, right? If you don't do that, then it will not provide a lot of value down the line. And then specifically, if you're using paid tools, make sure you're only running incremental scans as part of a development pipeline, because you have to finish within 10 to 15 minutes, whereas you have to run a full-blown scan in the QA or deployment pipelines. Sorry, QA performance pipelines. Why am I stressing this enough? Someone asked me a question on Twitter. So you're saying we should run full-blown scans on CI/CD pipelines? I'm saying, oh, I never say that, right? I'm just saying do meaningful compromises to gain security benefits. And coming to opportunities, if let's say a developer is trying to, let's say, code something, and your security tool caught an issue saying that, oh, this is a high severity issue, blah, blah, blah. But since it does not have context, just like all static analysis tools, it marks it as high severity issue, but in fact, it could be low or even informational, because static analysis tools don't have context. Whereas if you look at IAST or RASP, they have context. So they can make meaningful decisions based on the context. That static analysis doesn't have that. So that's another problem. Same applies for secret scanning as well. Now, coming to opportunities, if set up properly, it can provide lots and lots of value. So make sure we reduce false positives and then fail the builds. Please, by default, don't fail the builds. You will piss off a lot of people. They will not be happy, and they will definitely look at you and say, oh, this guy does not understand false positives, all right, or the tooling. So operations tooling also has these false positives, but they do these meaningful decisions to reduce the risk of false positives. So if developers don't have problems with operations team, then security should not have problems. We can learn from their mistakes, right? That's the point. Now, a typical workflow applies again to secret scanning is this. So a person can create a code, and then he tries to merge with your Git repository, SV, and whatnot. You can run the scan there. Okay, there's hundreds and hundreds of places where you can run static analysis. You can run it on a developer machine. You can run it while it's being pushed to a Git repository. You can run it in a CI/CD pipeline. You can run it in staging. You can run the secret scanning again in production. You can run the secret scanning thing in the production environment, or while you're maintaining or operating the system. Right? So as you can see, you can put secret scanning, a static analysis in general, while a person is coding, right? While it's being pushed, or while it's being used in a CI/CD pipeline, or while it's being packaged, while it's being deployed, or while it's being maintained. So it's up to you to decide which one you should pick. Okay. Now, what I will do is I will explain what are the pros and cons of each of these methodologies, and then I will let you decide. But I do have some bias in terms of where I think it will provide more value, and where it doesn't work nicely. Okay, so I can share my personal experiences as well then. Okay, let's talk about a person is now trying to code something in his laptop, right? And he might be using Visual Code, Vim, Visual Studio, or Vim, or any text editor. You can try to apply some rules there, and then say, as soon as he saves a file, I'm going to run a scan to ensure he's not leaking secrets of organizations, organization secret. We can do that, right? That's the one place to do. But I don't typically like that kind of integration. Can someone explain me what could be the problems if we integrate the ID spell checkers, or the secret scanning in the ID? What could be the problems? I'm not saying it's not providing value, but I'm asking you, there are some downsides to it. There are pros, which is like developers can find issues on a very fast, on a very short frequency. But what are the problems? What do you think could be problems? You don't have to be right, so please feel to. Okay, performance, yes, definitely. I agree. I will comment on that shortly, but I want others to think about it. False positives, yes, definitely. Developers can skip the test, yes, amazing point, whoever that is. So developer has administrative access to his machine, right? He can just disable it. And if you are saying, oh, my developers do not have administrative access, then you are not following what DevOps says, right? Give people tools and technologies and help and culture to do their job properly. Yeah. So probably, yeah, developers can skip the test. Yes, what else? And again, the technology doesn't matter here, no matter what you are using, Java, Python, Ruby on Rails, Scala, Golang, doesn't matter. We are talking about fundamentals here first. They may use different IDEs, yes. So that's the biggest problem security faces, right? I have Python, Ruby on Rails, Java, and whatnot. I have even seen Lisp being used in some organization, like C, very ANSI, like 90 version, and like it's just crazy. It becomes crazy. And some people even use like weird languages, Rust, R, you name it. Yeah, it becomes very, very difficult to support all of those. So you, as a security team, can you afford to support so many tools? And you need to at least hire one person dedicated just for running these tools, helping your developers run it. One person full time. He will not be able to do anything else. Trust me, I have done this. Okay. And you will sometimes also become build engineer. Your job is supposed to be security, but you will become build engineer. So that's another problem we have there. Now, coming to the most important part is the performance. Okay. False positives is also there, but the performance aspects come also into play. What do I mean by that? But that's why I was stressing, you have to know the fundamentals before you go into tools. Tools do not matter. You have to first work on people, processes, and technology. There are a bunch of tools. You will figure out the tools. If not now, 2 years down the line, 3 years down the line, eventually there would be some tools. Okay. So yeah, fundamentals, just talk about it. So how the way these tools work is that as soon as you save a file, they kickstart the scan. Now, and then another tip I could share with you is if you want to really implement DevSecOps, read and write more about human psychology, the culture, and the processes. Right? Yeah, different operating system also could be a problem, right? People can use Mac, Windows, Linux, and whatnot. And to be very honest, we are still not able to do security monitoring properly when we have different operating systems. Supporting developers would be a different case altogether. It's another challenge in itself, right? So there are limitations there. Yeah, coming to performance. So every time you save a file, these tools kick in. You can definitely set them up however you want. Maybe you can say scan once a 10 minutes and things. And if you're using, fortunately or unfortunately, plugins, IDEs like NetBeans or Eclipse, you can just say goodbye to your IDE for at least 5 minutes. Okay. Now you might be wondering, this guy just hates IDE checkers. I don't. Okay. But I can give you this information. I deployed IDE checkers for 15,000 developers across an organization, right? And then I monitored that situation for a month, right? And then I monitored again in the next month, and then on the third month. And you know the graph, how it looks? It looks like this, right? So when I installed, everyone was using it. Exactly after a month, 67% of them are not using it. And then if you go even further than that, only 10% of the people were using. So I did a small survey. Who are these 10 people, right? Guess who they were? They were interns, the juniors, and then the people who don't use IDE very often. These are the people who are using it. But the people who were supposed to use it, which is the people who contribute code to your repositories on a regular basis, they disabled it. And we paid about like how much? 150K USD for that tool, for about 500 or 600 developers at first, and then I don't want to disclose the final sum, but then they can be really, really expensive. Licensing could be expensive. But then some of you can argue, oh, hold on, this looks like a vendor pitch, right? I'm not. As I said, tools do not matter. So you can use something like GitHub, You can use something like Talisman, you can use Git secrets and whatnot. There's just lots of tools available, even free tools, to help you achieve that. But again, let's look at the problems right now, right? So and then the survey also talked about, why did you disable it? Why are you not using it? Because this guy is bugging me. I'm trying to solve a problem which is it's very difficult problem. I don't know what's going wrong. I'm not even able to fix my development problem. You're asking me to fix my security problem. I don't have time for this. Sorry, Imran. I will not be using this anymore. Right? That's it. That was the end of the entire program. The next year, we didn't renew the license. Okay, so these are some problems. So to summarize, you will have performance problems. There will be false positives, right? It's a sure recipe for disaster if you don't provide real vulnerabilities to your developers, not false positives. We want true results, right? And then developers can disable it. Again, you're losing that trust but verify concept, right? Audit wants verification, so we are losing that. We don't know that, right? Developers use different IDs. That's another challenge. And all of the paid tooling in the world, they support a couple of IDs, mostly for Java and .NET, because these softwares are targeted towards IDE in Java. I have nothing against vendors, as I'm mentioning. There are good tools out there, but you have to know where they shine and where they don't work at all. That's a problem. Different operating systems is another problem. Licensing costs is another problem. And then they don't allow you to enforce the policy across the organization, right? Right. So while building, that's what is happening. Now, while committing, now let's move on to the next stage, which is now your developer has moved from, so we are coming to Git hooks now. Okay, that's what I'm currently doing. So your developer is done with developing this code, whatever functionality, and he's trying to now push to production, right? So tools like your Git secrets, we have a couple of labs here, but unfortunately, I'm only sharing one lab here. But let's say you have this tool called, hold on, pre-commit. This one specifically. This open source tool, and all of the tools which I'm going to show you today are open source. Okay, you feel free to apply these concepts to paid tooling as well. Okay, so if you look at pre-commit, what we are doing here is as soon as he tries to push or commit a change in his repository, he's not pushing yet to the Git repository. He's trying to commit it first, right, to his local repository. Then you can run these tools like pre-commit is one, Bandit is another one. Talisman also provides you this kind of like pre-push hook, right? There are different types of hooks. I don't want to go into it, but think it like this. Before it lands into Git repository, you're running some tests. Again, forget about what you're running. You can definitely do static analysis, SCA here, or secret scanning and whatnot. So you can do lots and lots of tests, but yeah. Now, it's good, right? Your developer is trying to push code. Now, then you are running scan, not while developing stuff. This is great, right? If you can afford it, you should do it. But what's the problem here then? So it's also not perfect. As I said, what could be the problems if he's trying to commit code and then you are running the scans and blocking him, so to say. Again, do not block, please, but saying. Yeah, what could be the problems? False positives, yes. DOS, yeah, could be reasonable. Yeah, you might just bombard him with a lot of information and just too slow if it's not configured properly. Yeah, what else could be the problems? Cannot commit. Yeah. Incompleteness could be because yeah, that's true. Because you cannot run a full-blown scan here as well because you want them to commit immediately and move on to the next task. Yes, I agree. Or else? Think about it. And even DevSecOps, if you look at it, it's application security in DevOps setup, product security in DevOps setup. So it's not much different, but you have to know all of these, which is what we are trying to discuss today, right? The control is still in developer's hand. Yes, could be an issue. Must be supported in different operating systems. Yes, most of these tools also ask you to use Unix or Unix kind of system, Mac, Linux. Some of them don't work in Windows, but if you use Git Bash, yes, it works. So yeah, that could be a problem. So yeah, I think these are some of the problems. You should think about it. But none of these things matter. Remember, I stressed a lot on culture and then technology, right? So the problem is not technology, the cons, apart from all of these cons, that when a developer is trying to create some code, right, he does not push only one commit. He does multiple or even hundreds of commits on a regular daily basis. And if he's really pissed off and then you're trying to build in security, it could be any stuff, then they will disable it. Again, same problem like we had in the IDE. You piss off developers, they will disable it. Now just think about it. If you have to log in into a website, you have to click on 100 buttons, then you will log in. I'm sure this will be awesomely secure. It would be like military installation, but then no one will using it. So you have to have a good balance between usability and security, right? So that's another problem we have. Okay, so let's move on. So good interaction. Thanks a lot, folks. Really appreciate this. Okay, right. Next, moving on. Let's say now you have put this into CI/CD problem. CI/CD. Now, again, amazing place to enforce secret scanning, right? And this is where I like secret scanning to be. Okay, but there are some problems. Just like everything else, there are pros and cons, right? What do you think are pros of using secret scanning as part of CI/CD, which is what you will do an exercise today? You will put the truffle hog as part of CI/CD pipeline. You will run it on every commit or every merge request, pull request. You'll see that. We'll do 2 exercises in about 5 minutes. Yeah, what could be the problems when it comes to embedding CI/CD testing as part of CI/CD problems? Yeah, secret scanning as part of CI/CD problems. Okay, so I'll add context there. So CI/CD systems should be only one across the organization, at least couple of them. So one answer here is it could be expensive. Yeah. False positives again, false positives is there across the static analysis. It doesn't matter where you put it, there would be false positives. Commit secrets in public repositories. It's too late. That's the answer I was also looking for. It's already too late by the time you push to a code. If it's public, you can go bankrupt, to be very honest. We know companies who went bankrupt because their secrets got leaked in Git repositories, right? So the pros could also be, so that's a con, right? Expensive. You are committing secrets to code. Now you have a history. People say, right, whatever happens in Vegas stays in Vegas. That's true for Git also. Whatever happens in Git stays in Git. So you cannot delete it, kind of. Or it's pretty expensive without losing your history, the Git history, which can add value in the development lifecycle. Right? It's difficult, doable, difficult, but as our friend here says, it's too late already. Okay, so that's the con. But when it comes to pros, you have now trust but verify. No one can disable it unless someone is doing a code review or approving that request. So the first benefit, you have trust but verify. You did not have trust but verify in the build stage or in the static analysis stage. In the pre-commit or pre-commit hooks, right? You didn't have, and you cannot enforce it across the organization as well in some cases. So that's another problem we have there as well, right? So that was the problem. Now this solves it, but then it adds new problem now here. Your secrets are now in repositories. Right? That's a con. Now you have to now pick up what is important to you. Is it that the usability, developer experience is important to you? Or you can say, okay, I will let the secrets being committed to my Git repositories because if they do it once, probably they will learn from this experience and not push those secrets. And then your next step would be to ensure we don't store any secret. There shouldn't be any need to store secrets as part of code. Probably you store them in environment variables, or probably you store them in some secrets management service like LastPass, and then you can make API call and get it if that's the case possible. Or you can use a dedicated secrets management systems like Vault or KMS and Secrets Manager and whatnot, right? So you see now I'm balancing this. This is a balancing act. Nothing is perfect. You have to do this nicely. And again, there are paid and free tools to allow you to do that, but we are just going to use free tools. Okay, does it make sense, guys and girls, folks? All right, are you guys able to follow it and then understand what are the pros and cons? Yeah. So a lot of the courses online or otherwise, they concentrate a lot on this technology, which is just like a 1/4 of the entire DevSecOps processes. As you can see, there's a lot of things you as a automator or as a developer have to understand before you can put in, right? So please keep these things in mind. Okay, fair enough. So let's say we made a decision that we don't want to push secrets to our Git repository at all because we cannot afford to put it into environment variables. We don't have a dedicated system whatsoever. Then we will move on to the next stage, which is while we are deploying to staging, we will try to open up the artifact and then scan the files. And if we find any secrets, then we will not allow it to, deploy to staging environment, right? Sounds reasonable. Maybe you can now have here trust but verify. Definitely we can verify. Developers cannot disable this, just like how they could not do in CI/CD. And maybe you can enforce it in some way. Or if you're using something like Sonatype Nessus or JFrog, Docker registry, maybe you can do it there itself on the repository itself. Possible, right? So that's some place to do it as. But I think we are now, so I think the CI/CD system is a good balance between visibility and performance, right? Because when you are merging a PR, you don't merge the PR immediately. Someone has to do a code review. So you have still substantial amount of time before you commit this code to production, master branch or what have you, right? Feature branch, whatever. So you have considerable amount of time. And this is where I've seen most organizations do secret scanning. Now you might be thinking, oh, wait on a minute. Why not put this into operations team, right? Why not operations teams do this scan in the deployment stage or even in the production stage, which is what we call maintenance and operation stage? What are the problems there? All right, what are the cons of this? Why I wouldn't want to do it? Yeah, it's already too late, right? It could be too late. That's one problem, definitely. Next, what could be the other problem? Come on, you can think of stuff. Okay, a quick hint. Who does monitoring usually? Security monitoring? Right, security operations teams. Are they short-handed as well, just like everyone else in the security team? Yeah, that's the problem. Now we are saying move left because we want to find issues early on and also scale our security program. If you put in the operations, might as well just scrap everything, remove DevSecOps, shift left, and just let everyone do as it is, and everyone will be happy. We don't have to let anything. So that's the problem, and that's the problem we are trying to solve here in this aspects of thing. Yeah, that's why I don't like it to be in operations. It could be possible. We have tools like GitHub, TruffleHog, a bunch of other ones which help you do that. But too late, too cumbersome, and one person cannot scan every repository. As I mentioned, hundreds. You're competing against literally 500 developers or 1,000 developers. One person is doing that. That's why you see these typical problems with security people, right? There's a survey which says, okay, an average age of a CISO is just 17 months because he's in so much of stress because of all of these. And then even, someone found out, I can Google about this, that security people are more stressed than anyone else in the organization because they look at it's usually fear, uncertainty, right? Everything in security, you cannot guarantee or you cannot prove my software is secure. It's theoretically not possible to prove that. We can only say there is no defect yet, but you cannot say, oh, my product or something is 100% secure. Anyone would be, whoever says that would be lying, literally. Right? That's the problem. That's why they are stressed out. Right? So in order to scale this, so one of the biggest advantage of DevSecOps is you as a security person can sleep properly in night. That's the side effect of it, if I have to put it lightly. Okay, now let's move on. Now the secrets can be in your source code. They could be in your configurations. It could be in your infrastructure as code. They could be in your containers. Wherever you think the code can live, configuration files can live, you can do secret scanning there. Okay. Now look at the heading. I usually call it endemic, but it should be called pandemic. It's really a problem. It's a huge problem in the organization, right? And I know a couple of organizations, they spend millions on trying to avoid this exact issue, right? More so after GDPR, people are more cognizant or mindful of this fact that our developers can accidentally push code to public repositories or put secrets into them, right? That's why I believe CI/CD is a good compromise. It's not too late and it's not too early, right? I'm not against all of these. Definitely, maybe ideally, what I want you to do is start with secret scanning in CI/CD, and then also add as part of pre-commit or pre-push hooks, which acts like a defense in depth. So you have one layer of security on the box, but let's say developer disabled it, you still have some mechanism to verify in CI/CD, right? Defense in depth. Or you can also do it in the SOC. So yeah, different ways to put it, but ideally, bare minimum, you should have CI/CD. And if you want to put pre-hook commits, first do CI/CD and then go there. Because when you do in CI/CD, you will have visibility now. You can pinpoint, okay, you will see these trends. Oh, all my new developers are committing codes. My old developers are the ones who have more experience and not committing the code. What could be the problem? Oh, yes. So whenever they join our company, I have to do awareness training, a developer training on security. What things are acceptable in our organization, what things are not, right? That will help you gauge that thing, visibility. It will give you metrics to talk about. It will help you share this information with others. So yeah, if you can't measure it, you can't improve it. As simple as that. Okay, fair enough. So where do we store the source code? Secrets. They can be stored in source code. They could be there in configuration files and environment variables. So again, it's a huge blunder or a problem or pandemic if you store secrets in the source code. But guess what? Even companies like Google do it, right? So you might be thinking, oh, Google, Facebook, or these companies, fancy unicorns, they don't do it, right? Even they end up doing it. It's possible. It's sometimes it just happens because of lack of awareness or accidents and whatnot. So even they are doing it, but everyone is trying their level best to move away from this, right? Again, I'm not blaming Google or something, that every developer, some or the other part in his life, he definitely ends up committing secrets. Even I did that in some repository, of course, not a public repository. So definitely we should try avoid putting this here, right? And then if you can't use like a dedicated secrets management system, at least try to put it in a CI/CD, in a configuration or environment variable. That way, even if your code is compromised, you have some way of saving your secrets, because environment variables are not added to a Git repository or something like that. You could if you want to, but ideally these would be in CI/CD service, right? And next stage of that, right? So most of the organizations these days are in this stage. They are either storing the secrets in environment variables or in configuration management. And there are also a few, maybe let's say roughly, again, don't quote me on this one, roughly of what I've seen, about 60 to 70% of the organizations are doing these things, storing secrets in environment variables and configuration management system. I know about 20% of them are using dedicated secrets management system. Either they could be because they are on cloud, or they're using something like Vault and different other systems, right? And like everyone else, yeah, there's definitely issue with storing secrets in source code as well. Okay. So yeah, so those are problems as well. So ideally, eventually, I want to go to secrets management systems, but that's not possible always. There are limitations because of technology, pricing, and what have you. This is pretty complicated topic. You cannot just go in and say, oh, can we just use secrets management system? And they'll say, our code is like 10 years old, and we don't want to change it, because if we change it, we don't know if it will function ever again. And the guy who created it, maintained it, left the organization, I don't want to touch it, right? So you have to now find out other ways of solving the problem. Probably then you end up using environment variables. Ideally, yes, secrets management system for everything, but reality sadly is different than what theoretical concepts. So that's it. I think I have explained this enough. I will go into more details on. There are two types of scanners: regular expression-based scanners, and there is a entropy-based scanner. Basically, we are saying in entropy-based scanners, hey, does it look like English word? Oh, then probably it's not secret. That's what we are saying when we're talking about entropy-based ones. Okay, there's more to it. You can check out our courses if you wish to know about it. So regular based scanners, GitLab, they also do entropy. Some of them definitely do entropy. You can add custom rule sets to figure out your particular organization secrets as well. There's a repo scanner, there's a truffle hog, which does entropy. They also do regular expression, but I think they shine where they use entropy based stuff. We did some research on trying to find out which tool does what. I think I removed it here. Okay, here it is, quick glance. I'll not talk about it. But basically, these tools are, again, not perfect. They have pros and cons. Some have some functionality, others don't. So what we'll do now is, all of you, let's open up your browser's lab environment. And we will do now the first exercise, which is truffle hog. Or even before that, let's do a manual one. So go to the portal, click on the courses button, and then let's look at secret scanning using truffle hog, where we have different tools in the labs. This is just one such tool. We do so we help you learn all of those concepts which I talked about, right? Pre-hook, pre-commit, IDE, production, and whatnot. But this is, today we are talking about DevSecOps. So yes, so this is a tool. I spelled it wrong here. So truffle hog helps you find secrets in source code, whatever that could be, configuration files, scripts, what have you. And what we'll do now is, first we will download the tool for the code. So the code we are going to scan would be this code. It's an open source project again. And then we are going to CD into it. We are going to go into the directory and check out what kind of code I have here. So this is the code. Looks like Python code, but I don't care. What I do care about is, do we have secrets? So let's do a poor man static analysis, secret scanner. Let's search for if I have password like, password. And then let's look into, let's look into something like in this entire directory. Okay. Oh, look at that. Yes. Lots of issues. Now, can someone tell me, all of these issues look like real issues to you? Yeah. No, some are variables. Yes. Yeah. So these are not issues, to be very honest. Most of them, like 90% of them here, are false positives. Some are comments, some are variables, some are just plain information, right? They're just explaining. All of them with .html here are, false positives. Oh, interesting. Maybe we can improve it further, saying that anything which has password equal to in it, probably that's how you will find out secrets. Click on that. Oh, look at that fancy thing here. Interesting. So we went from 100 issues to 2 issues. Do you think this is an issue here? Does it look like an issue to you? Yeah, it is not an issue. Okay, it's not an issue. They're just piping it to a variable and all of that. Oh, maybe actually there must be some variables where they have space after and before. Oh, look at that. So this guy did not find this or did not find this where they had spacing. Hmm. Okay, fair enough. What about if my password is admin? Yeah, caps. Good, 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 good suggestion there. Thank you. Okay, there is something called admin here. Hmm. Let's see what else I have. Oh, lots of garbage again. False positives. Right? Now, this is your poor man's static analysis or git secret scanning. Right? As you can see, there are a bunch of problems here. Right? It cannot talk about, is it in variables, is it in comments, is it in as part of function variables, or is it as part of the real stuff? Are we looking at admin as a password or username as password? And there's a lot of permutations and combinations which can happen if we use grep. Right? That's why grep is not so good at finding secrets. But truffle has two scanners, as I mentioned. They have both regular expression scanner, and then they also have entropy based scanners. Okay, we can enable and disable them appropriately. Okay, let's move on. That was just we went tangents there, but the exercise now talks about, let's install this tool called Trufflehawk. Let's install that. Click on a button, it's done. Can do it even on iPad or a browser, mobile browser, right? Okay, so we saw this, fair enough. So let's see what Trufflehawk does. What kind of help does it provide us in trying to find out? Okay, so interestingly, it does entropy, which means that probably I can reduce my false positives a bit, not completely. Again, as I said, static analysis is prone to false positives. No one can offer you zero false positives without custom rule sets, without modifying it, doing false positive analysis. If they are doing it, they are selling you snake oil. As simple as that. Okay. You need to teach it because, as I said, static analysis is doing some compromises. We want speed, so we are reducing quality. We want quality, so it will increase the time, efforts, the processing power you need. Okay. The technology itself is not bad. Same goes with all the tools which I'm explaining. They are awesome tools. They are free tools. Please use them. But the problem is not in the tools, but the way you configure it. Right? That's the problem here. Okay, let's move on. So, okay, so we want to save the results in a JSON file. Fair enough, we'll do it. Okay, so we are also saying here, can you please find out, only enable the regular expressions which has high signal values, meaning they cannot be false positives. Interesting. Can I disable specific rules and add specific rules? Yeah, probably you're not using something like SSH keys or certs. So you can just disable all of those things in your organization. Entropy. So you can enable entropy by using this hyphen entropy. Okay, pretty interesting. You can even scan. You can say, okay, scan from this moment in the history, maybe scan from past 10 years, not more than that. So if you have a commit history of 20 years, I don't want to go so far in past. So you can say, okay, scan from this max depth, how deep you want to do the scan and which branch, right? Do you want to do a master branch, a development branch, what have you? Right? You can exclude paths. This is very, very important. If you're not excluding testing files, some files which are only used for testing or development, then you are up for pretty bad time. Okay, so please feel free to do that. Okay, now let's move on. Let's see what this tool is, this exercise is trying to teach us. Again, we don't try to teach you everything in one go. These exercises are 10 minutes at max, each exercise. We do these things separately. Okay, so we're going to run this. We're going to say, can you please run Trufflehawk on the local directory, on the current directory? The dot means the local directory, present working directory, and give me the results in JSON. And if you notice here, I did not enable regular expressions. I did not enable entropy, right? So you should be wondering, then which one does it do then? Does it do the entropy or does it do regular expression, right? I don't know. That's a homework for you. Figure that out. Okay, I'm just clicking on this link. Oh boy. Oh, so many issues. Let's look into these issues one by one. Okay, clear the screen. So where did we store this? In a file called secrets.json. Secrets.json. Okay. So there is something called branch here and it ends here. Can someone tell me, is this a issue or a false positive? Yeah. Hello, folks, please. What do you think? This is a real issue or false positive? Again, this is all guesstimates. False positive. Okay. False positive. Fair enough. SHA checksum. Okay. Could be false positive. Fair enough. But guess what? You can never know unless you look at the file. So he's saying this issue is in this file. Okay, let us go and look into this file and see if we have really any secret there. Let's do false positive analysis. Oops, damn. Who commits the hashed password and username and passwords emails? Oh, this looks like customers data. Oh shit, right? It did find issue. Very interesting. So we can mark it as issue number 1 is a real issue. Move on, let's go the false positive analysis here. Let's look at the second issue here. Okay, second issue looks again looks like a issue. This definitely looks like a false positive, and so on. You go and so on and so forth and try to see if this is a issue or not. Right? Let's look at one more issue which is a false positive, and then we will call it a day, and then you guys can do this exercise. And then we'll put it into CI/CD pipeline in the next 5 minutes or so. Okay, looks like SHA sums, lots of them. Yeah, as you can see, you just do a typical false positive analysis and all. But the signal to noise ratio on this is really, really bad because we didn't configure the entropy, we didn't enable the reduce the false positives, we didn't teach it what are you expecting in your organization. So yeah, the tool itself is pretty good, but the way you configure matters a lot more than what you think. So yes, so that's a problem here. Okay, so what we'll do now is we will run this exercise. All of you can go to this link here, right? I've shared this in the chat. Go here and start off from the beginning, right? Okay, if you're stuck or you think the portal is not responding or for any reason, right? Or just you want to see how this works, just refresh this page, everything would be back to normal. You can start from scratch as if you have a new system, and it is a new system in fact. Okay, as you can see, you can just refresh it, click the button, start, move through the exercise. Okay, go on, do the exercise. We'll meet again in 5 minutes. Okay, so we are back from the exercise. Let's talk a little bit about the next steps here, right? What we just did and what we learned as part of this. So we use Shufflehawk to scan for secrets in the code of one project, right? It happens to be a Python, but then there are other exercises where it's in Java, Ruby, and whatnot. But then again, it doesn't matter as long as you can use the regular expression scanner or entropy scanner to find out the secrets, then you can find it out in any way, right? Now, this is interesting, but then some organizations have even gone further by creating static analysis tool for finding the secrets, right? It sounds weird, but then this is a tool which I'm talking about. So what Lyft did, this is what I was explaining you about in the last the DevOps chapter, which is that they created a plugin, high entropy plugin for Bandit. Now, what happens if they implement this is because Bandit uses AST, it has all of this context built into it. Is it in the variables? Is it in the function name? Is it in the comments and whatnot? And comments it will not find definitely. But you see, it becomes even more powerful now because you're using AST to find secrets, not regular expressions. As we saw, regular expression could be very hard to write. It could be prone to a lot of false positives. So if you can afford this, use this. But problem here, again, just like everything as I explained, this is pro of it. There's also con. This can only work on Python source code because the bandit uses AST of Python. So for you have to write for Ruby on Rails or Ruby, another entropy strings plugin, and then for something else like that. So you then go on exploring rabbit holes. So that's the con of it. But if your organization is only Java or only .NET, maybe you can use something like an AST plugin to even reduce your false positives further. As we mentioned before, there are false positives in this in the results. So now, question for you guys. Do you think now you should fail the build based on this information? We had about like only couple of real issues and probably like 60 to 70% of them are false positive. So now, do you think we should fail the build based on this information? Can you please type in yes or no? Yeah. Why no? Someone said it depends. Okay, but here it's not, buddy. Seriously, yeah, it does not here. Please don't fail the bill when you have false positives. Right? Oh, okay. So some of you are saying yes. What is your reasoning of failing a build even though we have lots of false positives? So we only were able to find 10 real issues. The rest of the 90 were false positives, right? So yeah, what's your reasoning? Again, I'm not trying to judge you. I'm just trying to understand what's your reasoning behind it. Probably I will learn something new here. There were genuine issues that could be a risk. Okay, fair enough. Okay, someone is saying that you can fail the builds only on genuine issues. Now, how would you categorize an issue is it genuine or not? If it was possible, then tool would have done it for you, right? Think about it. Okay, so we are not going to fail this build, okay? So we have created a maturity model called DevSecOps maturity model, which takes you through these steps, which says that in maturity level 1 and 2, we are not going to fail build because we didn't write custom rule sets and there are false positives. We will not fail the build, even though there are issues. Why? The visibility is more important than fixing and finding issues here. Right now, in maturity level 1 and 2, visibility is far more important than finding issues. Why? As I mentioned, if you cannot measure it, you cannot improve it. Right now, we are trying to go into the tribe of developers, trying to convince them to help us do security properly, where we are also promising if security is everyone's responsibility, right? So, yeah. So maybe alert on a PR, yes. Alert, yes. Failing a build, no. Too extreme. Okay. So yeah, please don't do that. Please don't fail the builds. Eventually, we are going to fail the builds. I'm not saying don't fail at all, but we're gonna do it. Yeah, another technique could be like how our friend here mentions that we could not fail builds in dev environments and fail only on stage or prod environments, right? Or maybe we can say fail only on staging environments, not on the production one, because maybe the reason, again, psychology issues, and those issues are predominantly not related to security. It's usually human psychology. And if you want to do really good in security, read human psychology first and how to write and read English mostly. Why am I saying that? We being technical people, because you have to now convince them that, hey, these are the things which are meaningful for us from an impact perspective, risk perspective, right? Again, the reason from a psychology perspective, the reason why we don't want to fail the production environment when we still have false positives is because they found a critical bug or a vulnerability in production and they are deploying a fix, a hot fix. And your build, now your tool is blocking them based on a false positive that you cannot go to production. Now imagine that, the frustration they would be in, and they will just disable it altogether. So you lose whatever visibility you had, whatever work you did, the entire organization creating that culture, you will lose it. So please, please, please don't do it. At least, yeah, they won't collaborate with us. So that's the main point, collaboration, right? As I mentioned, people first, processes, and technology, and that order matters. And fortunately, unfortunately, usually unfortunately, we concentrate too much on technology and then alienate everyone. That's why the security was left behind in DevOps process. So please, please, please don't run any scan which takes more than 10 minutes. Don't fail the builds based on false positive data. Okay, that sounds pretty different, but then we have seen this again and again. It works, and this is how it scales. And if you do this, what happens is your mean time to remediate a vulnerability will reduce from 2 months to 15 minutes or 2 years to 15 minutes. What do I mean? The moment you open up an issue in a Jira or some other version bug tracking system, it just sits there because you are making them switch context a lot and you're not giving them information while they need it, when they need it, and in a right format and in right level of quality, right? So yes, so please think about it. Again, as I said, there is no silver bullet. There is no right and wrong answer. It's depends. You have to make meaningful decisions. We talked about that. Okay, I'm wasting a lot of time here, so I don't want to do that. But what I want to do next is I'm going to embed this task now. Now, if you don't know GitLab, don't worry about it. Okay, there are a bunch of tests which you can do in different CI/CD systems. All of them are almost same, kind of equal to each other. They do exactly the same thing. Maybe I don't want to do it in the test stage. I want to do it in the build stage. Right. So maybe I will just move this guy, and I'm doing deliberately manually, right? Because I want to show you how easy it could be. So I'm just copying whatever stuff your developer did it. Yeah, and then I'm just going to say, okay, build stage. What was the command we did in the exercise? Okay, the code is being downloaded anyway. Let me just copy this guy here, add it here. And what was the other command which I was using here to do this? Probably this. Okay. I'm not sure if T is installed, but I'm just going to redirect it to secrets. And then I'm going to store this secrets. Okay, always true. And I'm going to, yeah, save it now. Okay. Git, so I'm just committing this code to Git repository. It will kickstart a pipeline just now. We'll see that. As soon as I make any change to CI pipeline, it will run the scan. And the way I set it up is it will run on every commit, every push on every branch. That's how I set it up. But you can decide when to run, how often to run, all of that. It's pretty flexible on how you do it.
Did you,
again, tool doesn't matter.
Remove the front end one because that was failing before, wasn't it?
It's here, right?
Here, okay. So it's gonna fail probably. Maybe. We'll see.
Yeah, that's there in the last stage, right? In the secret stage, it's not there. Okay, there you go. The job is successful. It uploaded the result. You can download this result here and then enjoy the artifacts and the results. And again, exactly the same results which you will see. And yeah. Oh boy, hold on a second. Why did Trufflehog did not fail the build when it found the issues? Interesting. Right? Go check it out. That's your homework. But okay, ignore the allow failure. But even without that, it passed the build. It did not fail the build. Right? Even though there are issues, it failed the build. So does it mean the tool does not support it, or it doesn't have the functionality? Maybe check it out and let me know on Twitter or somewhere else. We can then discuss it further. Right? Yesterday I gave you the homework of Retire.js. This time it's Trufflehog. Why it did not fail the build? Okay, go on, do the exercise. We have about 5 minutes to do this. Does that sound good? Okay, so we are back from our exercise on implementing DevSecOps pipeline as part of CI/CD pipeline. And we have implemented so far in the past 2 days this kind of pipeline. So we are starting with the build pipeline. That's where we are doing a secret scanning. And then under the testing phase, we are doing front-end SCA, dependency scanning, and the back-end dependency scanning, and then the usual test. There's more to it. As I mentioned before, you can run a bunch of tests in the release phase, deployment phase, production phase, and even in the maintenance phase for compliance as code, chaos engineering, and fuzzing, even fuzzing for that matter, or pen testing or red teaming automation. Right, so there's more to it. We just scratched the surface on this one. So if you're interested to learn more about what we have to offer, please do check out our website and for more courses there. Right? Thanks a lot, everyone.
Any
questions? I think we're done.
Okay, thank you so much, everybody. I will stop the recording now.